Embedded Controller Lab additional experiment. It is to run the program in Proteus. So we write a hex key program, and we get a hex file out of it, and this hex file has to be dumped onto the IC, and we will be using ARM7 microcontroller. The device is LPC2148. So already it was discussed how to pick this header file. You can try to execute this program. You require two tools, Keel and Proteus software. So I'll explain the code, what modification is essential in case if you want to simulate the hex keypad program, and if you want to run it in Proteus platform. Now, header file change, and string.h lcd.h. Let us look at what is the value, what is the data which we need to feed in lcd.h. So lcd.h program, as addressed, this will be having a delay function. Delay function is same what we have defined, the delay for LCD module. LCD data program, there is a difference here. We had used a different pin in the Proteus program. We will be using port 1, and in port 1 we will use pins starting from 16 to 26. I repeat, port 1 16 pin to port 1 26th pin, altogether 11 pins we will be using. Hence the data which you need to pass onto the port 1 is from 19th pin onwards. 19th to 25th 26th pin we will push the data, and that's why here value is shifted by 19. And 5 followed with 40. This is to ensure that the enable is made 1, and also the register select the pin is made 1. This is for data. And while so this 1 implies you make enable loop. Okay, this is for data. Similarly, for passing the commands, we use 100. Enable is made 1, but the register select is made 0. That's for command. Okay, and here it is 0. So hope this is one difference what you have. Other than that, everything is same, and we cannot make use of string length command when you are using the LPC 2148 directory. Okay, so that's why we require this. So if you're using it in LPC17x6 controller, then you can directly use string length. That's how you're gonna get length. Otherwise, evaluate the length using this concept. Okay, and this was already discussed. So this way you place all the functions, namely delay, LCD data, LCD command, LCD string, and LCD init. Okay, place this function in LCD, name it as lcd.h, and include that file or add that file to this project. So now this project literally should have two files, one .c file and one more header file which you are including. And since it is a user defined header file which we have created, so it should be enclosed within double quotes. Okay, and this is the code. So for keypad, you don't have any modification here, because we will be using same ports. Port 0 itself is used. Port 0, 05 are used for input, and 06 to 09 are used for output. Hence this code for 01, 02, 03, 04 or 01, 02, 03, 04 doesn't change. I1, I2, I3, I4 doesn't change. CLR doesn't change. Same. Only few things which gets modified happens to be this command IOCLRO you will be using, or IOCLR0. So in LPC17 you will replace it with LPC underscore GPIO. Then we will be using FIOCLRO. It is FIOCLR, that's equal to IOCLR. Similarly, IOSET-O is equal to, in LPC 1768, it is LPC underscore GPIO, then arrow mark FIO set. Okay, so remember the modification which you require. So this is exactly same, no change, no change, and here no change, the method. And scan function, there is one change. IO pin 0 you will be using. In LPC 1768 this was replaced by LPC underscore GPIO and arrow mark. Then we pick the register FIO pin. Okay, and same pin LPC underscore GPIO arrow mark FIO pin that was ended with 3C. Okay, so wherever you find IO pin 0, replace it with FIO pin 0 or FIO pin of the corresponding port 2. If it's, then you have to use it using the command lpc underscore gpio2. Now it is gpio 0 you're using. Okay, so hope these two programs are clear, and can try this. Okay, after writing the program, as usual, go to output options for the file, header file. You don't have options for header file, rather you have options for your key file. So option for target. So here linker, check mark this use memory layout from target dialog box, and output check mark on this create text file, give OK, build the application .c file. We don't have any problem. Then rebuild, we'll get a hex file. This hex file has to be dumped. Okay, now here we will minimize this, and let's talk about the schematic structure, how it should be created, what are the components existing. Okay, now let's concentrate on hex key. How do you get this keypad? Okay, for this keypad, so you will use button. So you have to go to pick device, under that select button. So you have a button addressed. Okay, so I'll just show you once. Here you just type button. Okay, so this component you have to pick SPST push button. In my case it is already selected, so ensure that you have 16 and make the connection as it was shown earlier in this PPT. It was already addressed how the structure should look like. So ensure that this will be the structure. Create a schematic something like this, but don't connect LED now. Rather than that, we will be interfacing it to microcontroller. So in this, once you are completed or done with this, so make sure that you use PO. So I'll just show you. This is your port 02. Port 02 line is connected to the first column. Okay, this is your first column, so it is connected to first column. That's what is expected. Then P03 line, which is over here, and it is connected to second column. This is your second column. And your P04, which is this line, P04 line, and it is connected to column 3. That's correct. Okay, then finally we have P04, which is here, and this line is connected to, this is your P04 line, right? Oh, okay, sorry, P04 line is this. Yeah, looks wrong. One second. P04 is connected to, yeah, this is P05, last line, fourth column. P02, P03, P04 and P05. Now let's look at the row which has to be triggered as a output port. So we will start from P06. So P06 has to be connected to, this is your P06, and that's connected to row 0. Okay, this is your P06 and it is connected to row 0. Then you have P07, this end, and P07 is connected to yeah, P07 is this one, it's connected to row 2. Okay, similarly P08 is connected to row 3, and finally P09 is connected to row 4. So this is your circuit. And similarly use a power supply. So power supply you have, so power supply you can find it from this end. So here you have the node, device pin, terminal nodes. In this you have to pick power. I have already picked, so I'll just keep cancel now. Your case you have to use it, and use also registers. So register, my case I'll go to the component layout, register, generic register you have to select. So how to get this register? So here you type RES, and as soon as you press RES, you have a generic register symbol. You can pick this IC. You can set this to 4.7K as addressed in the schematic structure of X key, or you can make it as 10K, no problem. Just give it as 4.7K if that's correct theoretical value. Okay, and after once it has been connected, that is every one end of the key has to be, or one end of the button has to be connected with the help of a power supply. You have to use a resistor, and it has to be shorted. One end of all the switches are connected, that is on this column all switches are shortened. Similarly over here, all one common end is shorted, and it is provided with the supply voltage with the help of a resistor. So same has to be repeated for other columns. So on to the row side, so the one more terminal of every button has to be shortened up. So here you can see this is shorted with this again is shorted with this, and this center is shorted with this, and this shorted another end has to be given to the output terminal. Okay, so hope this is clear, it makes sense. Now let's move on to the LCD module. So we require LPC microcontroller, LPC 2138. Hope you can you just type LPC 2138 to get a controller belonging to ARM. Pick this unit, and in my case already I have placed the device. This is your main controller. Okay, and moving back to the schematic, here we will look at the LCD display module. LCD display module, what we will be doing is we will connect P0, P1, 16, because we are having only 16 pins of port 1. So port 1 16th pin to port 1 31st pin you have. So out of which 11 pins we will make use, that is port 1 16 to port 1 26. So 11 pins you have, but port 1 17 pin we will not use, because we know that for writing a data onto the LCD, your read and write pin can be made permanently low. So read write pin is made low here, and other pins are connected in this manner. That is P1 16th pin is given to register select, that's your RS pin, fourth pin. Then RW is grounded, enable is your P1 18th pin. Then P1 19 to P1 26 pins are for D0 to D7. So give the connection as shown, and along onto the left hand side of this controller, this is not essential. Reset button you do not have to configure. This is to ensure that once you type the button, in case if I want to make it clear, then you can use this button, so it will run from the beginning. Okay, so one more thing what you can include is you can use this crystal oscillator. So how to pick this oscillator? You just go to pick device, and here you type oscillator or crystal. You can give crystal oscillator, or just type oscillator, quartz crystal oscillator. So you have oscillator, crystal oscillator, crystal, yeah, crystal, quartz crystal. So select this device. My case already I have selected it, so this will be the symbol or schematic of it, and this has been picked here and connected to XTAL1 and XTAL2, two ends of this crystal oscillator, and change the frequency to 12 megahertz. Okay, I have to change it to 12 megahertz. It was mentioned as 1 megahertz, so frequency I have changed. So we'll see, to some extent I think I may have to change the delay also. We'll see. Then capacitor 22 picofarad I have addressed. So how do you get this? So again go to pick devices, type capacitor. Under capacitor you have different subcategories. Under subcategories select ceramic disc. In ceramic disc select capacitor with the 22 picofarad, that is this you have to pick. Okay, I have selected, so it has to be connected in parallel with this crystal oscillator. Then ground this terminal. So I repeat, this is not essential, we will not use it. Okay, then finally battery has to be given to VBAT, and V3 has to be connected to this. So after this, let me just double click. I'll click on this. The hex keypad .x file is already available. Just open it. Hex file I have created. Just click OK. Run the button. So I'll get the message here, 4x4 keypad text. Key, press the key. Okay. Now let us move on here. We'll just concentrate on this key button. Okay. Okay, this is okay. Okay, fine. This is okay. The structure looks good. Everything I can monitor. I'll just press this button and leave it. So you'll get 0. Now let me try the second row first column. Leave it 1. Hold, leave it. You'll get 2. Press the button, release, you'll get 3. Then again second column, press the button, release, you get 4. 5, release, you get 5. 6 button, release, you get 6. Hold 7, release 7, you get, then you get 8 working, 9 working, A working, B working, C working, D working, yeah, E working, and finally F working. So this is the simulation part. Hope this makes sense. If you're interested, you can build the program in your proteus environment and you can simulate the result. Thanks for watching the video.